going to be the start of, I think, one of our most important units and most interesting units is energy and conservation of energy. So energy is conserved. That means that the total energy doesn't change. For a system, but the energy can change forms. Okay, it can be potential energy, it can get converted into kinetic energy, maybe converted into heat. Okay, electrical energy, there's various forms, there's a lot of different forms of energy, but if I can somehow add up all of the different forms, I'll always end up with the same total. Potential energy is stored energy. And there are many different types. The one we're going to use most is gravitational potential energy. And for that, we're going to use the equation PE equals mgh. And it has to do with lifting it up to a height. If I'm holding something up high, it has a lot of potential energy. Then if I drop it, that potential energy will decrease as it's going down and turn into kinetic energy as the object speeds up. Now, we could also have elastic potential energy, and we'll come to this more later in the unit, but an example of that would be like a diving board. When you jump up and then go down into the diving board flexes, and while it's flexed, it is storing energy, and then it's going to straighten and kind of shoot you up in the air, and that potential energy is turning into kinetic. There could be chemical potential energy, which we won't use in this course. In chemistry, you might use it. That's the energy, say, stored in batteries, or actually in the food we eat. This is energy stored in chemical bonds. Okay. There's electrical potential energy, which we're not going to deal with in this particular unit, but when we start studying electricity, we'll be dealing with it. And that's, say, if I have a positive charge and a negative charge, they want to get together, I have to hold them apart. So while I'm holding them apart, I have some electrical potential energy. Then if I let go of them and they start flying towards each other, that potential energy is turning into kinetic energy. Kinetic energy is energy of motion. And the equation for kinetic energy is going to be KE is 1/2 mv squared. Now, solving conservation of energy problems, they're going to be similar to conservation of momentum problems. Probably going to want to sketch it if it's not drawn for you already. Then identify 2 points that you want to compare. Okay, it's kind of like before and after for momentum problems. We're going to pick 2 positions that we're going to compare the energies for. Find PE and KE at all points. And then set E total equal to E total. So here's an example. 100 kilogram roller coaster starts at the top of a 20-meter high hill. From rest, what will be its speed when it reaches a height of 5 meters? So it might look something like this. Now, the 5 meters could be on a second hill here, or it could be any 5-meter height. So we have the roller coaster cart there. This is 20 meters. This is 5 meters. Mass of this is 100. And here it starts from rest. And I want to know the velocity there. So I could call this point A. So I've drawn my diagram and I've identified my 2 points. Now I have to find the kinetic and potential energy at each of those points. So at A, we're going to say the PE equals mgh equals 100, g is 10, and the height is 20. So that's going to give me a potential energy of 20,000. And the units for energy is joules. And then the kinetic energy there is 1/2 mv squared, but it's going to equal 0 because v is 0. And then I can add those to get my total. And my total is just going to be 20,000 joules. Now, at B, we'll do the same type of thing. We'll do PE equals mgh. In this case, it's going to be 100 for the mass, times 10, times 5. That's going to give me 5,000 joules. And then the kinetic energy is 1/2 mv squared. So that's 1/2 times 100. Now I don't know the velocity, so that's still a variable. So v squared, so this is 50v squared. The total over here, we can say, is 5,000 plus 50v squared. And then I can set the 2 totals equal to each other. And I get 20,000 equals 5,000 plus 50v squared. Subtract 5,000 from both sides, I get 15,000 is 50v squared. Divide that by 50, and I get 300. And then v would be the square root of 300, which is 17.3. So on the next page, we have an example where the energies aren't going to end up equal. So for this particular problem, we're going to have some energy loss and friction. Energy loss and friction turns into heat. So it's not really lost, it just turns into a different form. It's not kinetic and it's not potential anymore. So here's an example like that. We have a 2 kilogram cart starting from rest of a 10 meter high ramp. So let's kind of draw that. We have that this thing is 2 kilograms. This is 10 meters high. All right, and then we're given that the velocity down here is 12 meters per second. And the length of the ramp is 40 meters. So those are the givens. Now, I'm going to identify my 2 points. I'm going to pick the top of the ramp, and I'm going to pick the bottom of the ramp. I'm going to find the potential energy here is mgh. So that equals 2 times 10 times 10, which gives me 200 joules. The kinetic energy here is 0 because its velocity is 0. It says it starts from rest. So then my total is 200 joules. At the bottom of the ramp, my PE is 0 because my height is 0. So since my height is 0, my potential energy is 0. My kinetic energy, if there was no friction, would have to be 200 joules because my total energy on this side was 200. My total energy over here would have to be 200. And it would all be kinetic energy because there's no potential energy. But in this case, that's not what's going to happen because we have friction involved. So it's 1/2 mv squared. So 1/2, the mass is 2. And we said the velocity at the bottom is 12 squared. So that gives me a kinetic energy of 144, which gives me a total energy of 144 joules. So the energy lost is equal to delta E, and it's going to be 200 minus 144, which gives me 56 joules. And we're going to learn a little bit more about the energy lost or change in energy in the next video. But remember, it doesn't actually disappear. Energy cannot be created or destroyed, but it turns into heat.